Hi guys, I hope everything's going okay. If you guys need anything, just make sure you email me. I check my email almost every day, so I can get back to you if you have any questions. This next unit is over 4 sections, so we'll have a section today, a section Tuesday, and then block day and Friday. And then on Monday you'll have a review, and Tuesday will be your quiz over this. So I'm going to teach all 4 sections for this unit. So make sure if you have questions over them, you email me. And then the sub will be back on Monday to help you with your review, and then your quiz will be on Tuesday, and I will grade your quiz. Okay, so we're going to get started with section 4.1 and 4.2. Make sure you have the guided notes packet. It should look something like this. That way it'll make it a little bit easier as you go through the video just to fill in the blanks instead of trying to take full notes. Okay, so the first thing we're going over is what a scatter plot is. A scatter plot is basically just a graph that has a bunch of different points, and the points don't follow any certain pattern. So the points are not linear, not quadratic, they don't follow any pattern. Okay, so 2 things we need to know about a scatter plot. First thing, the x, this is called the explanatory variable. Okay, and then the second thing, the y, this is the response variable. Okay, so in the problems that we do, anytime you do a scatter plot, you have to label the x and y axis. And in all the examples we do, they will tell you what the x variable is and the y variable, so it'll be pretty easy to label each one. Okay, so next thing we're going over is the best fitting line. Okay, so remember scatter plot, the points don't form a line, they don't form anything, they're just random points. So the best fitting line, or the line of best fit, is a line that goes through the averages of x and y. Okay, and remember average, we can write it as x bar, y bar. Okay, so this is like a coordinate point, the average of x and then the average of y. Once we have that point, it doesn't matter how we draw the line as long as the line, we try to make sure the same amount of points are on each side of the line. Okay, and then on your calculator, there's 2 ways to find x bar and y bar. The first way is on your calculator. Okay, what you're going to do, you're going to enter x values into list 1, and then you're going to enter y values into list 2, and then we're going to go to stat over to calc, and we're going to select option 2, which is the 2 variable statistics. Okay, and we will do an example of this. These are just the steps. Okay, for your quiz or your test, you will have to memorize these steps. So if you cannot memorize these steps, to do it by hand, the first thing you're going to do is add up all the x values And then the second step is to divide by the number of x values, or the number of x's. Okay, so that would give you x bar, and then just repeat that for y bar. Okay, so next thing we're given 4 graphs. Oops. And we want to know where we would draw a line of best fit. If it's an example like this, if we don't have actual numbers, then we're not going to find x bar and y bar, so we're just going to kind of guess where the line of best fit is. So remember, it has to be a straight line, and there can always be no line. So if we look at this first example here, if we draw a line anywhere on here, we're not going to have the same amount of points on each side of the line. So this one would have no line. Okay, if we look at the second example, the points are fairly close to a straight line. So just roughly estimate, if you draw a line, they should be about the same amount on each side. So right about there would be a good line of best fit. Okay, you come down to the third one, they're semi-close to a straight line again. So just estimate where you think a good line would be. And then the last one, if you look at the points, they're all over the place. They don't form anything close to a straight line. So this one would have no line. Okay, so if you flip to the back of your notes, we're going to look at the direction of correlation. Okay, a hint for direction of correlation, you're going to look at the best fit line. And the last part got cut off, it just says look at the best fit line. So there are 3 cases when we have direction of correlation. Case 1, if the slope is positive, then we say it's a positive correlation. Okay, and when we're talking about slope, I just mean the slope of the best fit line. So remember, a line that has a positive slope is going to look like this. It's going to start down low on the left-hand side and it's going to go up to the right. Okay, the second case, if slope is negative, this means that there's a negative correlation. Okay, negative slope is just opposite. It's going to start up at the left and go down to the right. The last case, if there is no line of best fit, this just means that there is no correlation. Okay, so if you look at the 3 graphs that you have, we're going to determine the correlation for each graph. So if we look at this first one here, start by the line of best fit. So on this graph here, I can draw a line that looks somewhere around there. It's a decent line of best fit. Okay, so now I'm going to ignore the points and I'm going to look at my line. My line goes from the left and it works up towards the right. So if we come up here, it goes from the left up towards the right. It means the slope is positive. So it means it has a positive correlation. Okay, if we go to the second graph over here, The points are fairly close to a straight line, so draw your line of best fit. Okay, this time the line starts up at the left and works its way down to the right. So if it goes up and then down, that means that the slope is negative. So this one has a negative correlation. Okay, and then the last example, these points here, they're kind of all over the place. They don't form or semi-close to a straight line. So since there is no line of best fit, it means that there is no correlation. Okay, so next thing we're going to go over is the strength of the correlation. Okay, we'll do more of this in section 4.3, but we're just going to introduce it today. So the strength of the correlation, the variable for this is just R. Okay, and this is called the correlation coefficient. Okay, so R measures the strength and direction of the linear relation. Okay, so again, there are three cases. The first case, if the points are very close to a straight line, this means that there is high correlation. Okay, second case, if the points are just kind of close, so we're just going to call it points are close to a straight line. Then this means that it's moderate or low. Okay, we're going to use both terms. So anytime it's semi-close, we're going to call it moderate or low. In the last case, if it's not close to straight, this just means that there is no correlation. Okay, and then two things that we're going to talk about. The closer R is to 1 or negative 1, the higher the correlation. Okay, then the second thing, if R is a positive number, this means that the best fit line has a positive slope. Same thing for negative. So if R is a negative number, then the best fit line has a negative slope. Okay, these graphs down here, they are not on your sheet, but we're just going to kind of look at them for a second. So if we look at this first graph here, the points are nowhere close to a straight line, so we would say that there would be no correlation. And then if you look at the R value, which comes from your calculator, R is 0. So remember, the closer R is to 1, the closer it is to a straight line. So since it's nowhere close to a straight line, R is as far away from 1 as possible. Same thing over here. Points are nowhere close to a straight line, so we'd say none. Okay, if we look at this one, the points are getting a lot closer to a straight line. So we could say moderate, I'm just going to call M, or low, so moderate or low correlation. And see, R is getting closer to 1. Okay, this one down here, points are very close to a straight line, so we would say high correlation. And if you look, R is almost 1. Okay, and then compare these two here. They're both very close to a straight line, so they would both be high correlation. This one, the line of best fit, would have a positive slope, so R is positive. This one, the line of best fit, would have a negative slope, so R is negative. All right. Okay, the last little thing on the bottom of your sheet, the least squares regression line. Okay, the least squares regression line, the line of best fit is called the least squares regression line. I'm just going to call it LSR for least squares regression, because the sum of these squared errors is as small as possible. Okay, so if you look at this graph here, it's not on your sheet, just look at the one up here. We have these points here, and this is our line of best fit. So the sum of the squared errors, these boxes here, this is the squared distance from the point to the line. Okay, so this is the line of best fit because all of these right here, these are as small as possible, so it's the best place to put the line. Okay, and we get this from the calculator again. So this equation you'll need to know, but then we'll find the different parts on the calculator. So the equation is y hat, so it's like a y with an arrow, equals a plus bx. Okay, and the different parts, y hat, this is the predicted y. A is the y-intercept. And then B is the slope. Okay, X is just any X value, so it's just going to stay X. Okay, so if you go to the next page of your notes, we're going to go over the steps on the calculator, and then we're going to do 2 examples. Okay, so the first thing we're going to do is we're going to have to enter all the values into list 1 and list 2. So to get to list 1 and list 2, we're going to go to Stat, and then we're going to select Edit. Okay, once we get there, we're going to enter the values into L1 and L2. Once we have all our x and y values in those lists, we're then going to go to Stat. We're going to arrow over to Calc, and then we're going to hit the number 8, which is linear regression a plus bx. Okay, once we select that, there are two different types on the calculator, so I'll show you both. But some of you might need to make sure that L1 and L2 are listed. If they are not, to list or to put the L1 in place, you're going to go to second and then 1 on your calculator. And for L2, it is second and 2. Okay, so once we have all that, if we just hit enter, it'll give us the least squares regression form or equation. We're going to do more of this over the next lesson, but I'm going to go ahead and give you the step because it should show up. So if r and r squared don't show up, you're going to go to second and then 0, and then scroll all the way down to diagnostic on, and then you're going to have to hit enter twice. So enter, enter. Okay, and this is in alphabetical order, so the diagnostic on will be all the way at the end. Hi. Okay. Okay, that's fine. All right, sorry guys. Okay, once you do that, then you need to repeat steps 1 through 4. Okay, so the last step, step 5, will be more for tomorrow, but it goes along with these steps here. Okay, so first example. I'll give you a second to read it.
My fault, wrong one.
You're fine. Okay, so they give us this data here. Okay, so I'm going to call body weight, I'm just going to call this the X variable. And then backpack, I'm going to call the Y variable. Okay, so the first thing that they want us to do is graph the scatter plot. Okay, so before I graph anything, remember we always need to label the graph. So we said X was body weight, so along the X axis here, I'm just going to fill in body weight. And then Y was backpack, so along the Y, I'm going to write backpack. Okay, so when we're graphing this, we're just graphing it like a standard coordinate point. So the first point, X is 120, Y would be a 26. So I'm going to go to 120 for X, Y was 26, so I'm going to go up to 26, and I'm going to make a little point. So the next point, X is 187, and then Y is 30. Okay, so go ahead and finish graphing all of the points. Okay, so it should roughly look something like this. Okay, so next thing we're going to do, we're going to find the averages of each. So that means we need to find X bar and we need to find Y bar. Okay, remember there's two ways to do it. I can add up all of these values right here for X, and then there's 1, 2, 3, 4, 5, 6, 7, 8. So whatever number I get when I add up, if I divide it by 8, that'll give me X bar. But we're going to have to enter everything into list 1 and list 2, so I'm going to do it on the calculator. Okay, so to do that, on your calculator, we're going to go to Stat. We're already on Edit, so I'm going to hit Enter. So I should get to here. If there is something in list 1 and list 2, scroll up so that the L2 or L1 is highlighted, hit Clear, and then hit Enter. And then I need to clear list 1, so I'm going to go over to list 1, up so L1 is highlighted, clear, and then Enter. Okay, so all of my lists are clear now. So under L1, I'm going to list all of the X values up here. So the first X value is 120. So I have 120. Second one is 187, 109. So just list all the way to 116. You should have 8 numbers entered, so make sure you entered all of them. Okay, once I enter the last X value, I'm going to arrow over to the right. So now I'm on list 2, and I'm going to enter all the Y values. Okay, to find the averages, I'm going to go back to Stat. I'm going to arrow 1 over to Calc, and then I'm going to hit number 2, which is 2 variable statistics. Okay, some of you might not see this screen. That's okay. If you do have this screen, go down to Calculate and hit Enter. If you do not have this screen, just hit Enter, and you should be able to have this should appear now. Okay, so if you look, X bar is the very first thing, so it's 136.125. If I go back to my calculator, if I scroll down, I should see Y bar. So Y bar is 28.625. Okay, so there I calculated the averages. So remember, when we graph the line of best fit, we have to make the line go through the averages. So that means if we write X bar, Y bar is a coordinate point, that's 136.125 and then 28.625. So I need to graph this coordinate point here. So if I go back to my graph, I graph X is 136.125 and then Y is 28.625. So just roughly put a point where that is. And then I need to draw an arrow to it and say that this is X bar, Y bar. So anytime you graph your line of best fit in an example like this, you need to label X bar, Y bar in your graph. Okay, so now it doesn't really matter what my line looks like as long as there's roughly the same amount of points on each side and it goes through X bar, Y bar. So I'm just going to draw a rough sketch of a best fit line. Okay, so it goes through X bar, Y bar, roughly the same amount of points are on each side of the line. Okay, so the next part says we need to find the equation of the least squares line. Okay, we already have everything entered into list 1 and list 2, so we don't need to do that. If you did not enter all those already, then you need to take a second to go through and enter all of those in list 1 and list 2. So since everything is entered, I'm going to go to, on my calculator, I'm going to go to Stat, over to Calc, and then I'm going to hit number 8. Okay, so in my X list, it should say L1. If it does not, remember hit second one. My Y list should say L2. So then I'm going to go down to calculate. Okay, if you do not have that screen, let me finish entering these points really fast. Okay, if you do not have that screen, so if you go to Stat Calc 8 and it comes up like this on your calculator, just hit enter and you should still have the same thing. Okay, so go ahead. We know the equation of the least square lines is y hat equals a plus bx. So if you look on your calculator, a is 16.265. I'm just going to go to 3 decimal places. So that's a, and then we have plus b is 0.091 x. Okay, so this all came from my calculator. So we know y is a plus bx. So we have y equals a plus, and then b times x. Okay, so remember we're not going to really work with the r's until the next section, but we're going to go ahead and talk about it. So if you look at both of these that I just did, if we look at this calculator here, r squared and r already shows up. But over here, there is no r squared and r. Okay, so if it did not show up on your calculator, you're going to go to second, 0, and then you should be at catalog. Okay, remember we're going to scroll all the way down to diagnostic on, and it is in alphabetical order, so it'll take 1 second. Okay, once you get there, hit enter, and then hit enter one more time so that it says done. Now if we repeat those steps, it should show up. So if we go to stat, over to calc, hit the 8, and hit enter, now we have our r squared and r. So since you already did this once, r squared and r should stay, but if it does not, just remember to go to second 0. Okay, so the last question, if a student weighs 146 pounds, what does the least squares line predict for the weight of the student's backpack? Okay, so right here, a student weighs 146. So if we come up here to our variables, we said that body weight was x. So this 146, this is our x value. It says the least squares line, so we're using this equation here, predict for the student's backpack. So up here we know backpack is y, so we're solving for y. So we're going to have that y equals 16.265 plus 0.091. This is just this equation here, but instead of an x, we know x is 146. Okay, so plug that into your calculator, you should get 29.557 pounds. Okay. All right, we're going to do one more example. So flip your notes over to the back. I'll give you 1 second to read through it. Okay, so in this example here, it says X is the age of the calf. So here for my scatter plot, I'm just going to go ahead and label the x-axis age. And then it says Y is the weight. So I'm going to label the y-axis weight. Okay, so again, the first thing we're going to do is graph the scatter plot. So we already labeled the graph. Okay, so our first x value is 1, the y value is 42. Next x value is 3, the y value is 50. I'll give you a second to go ahead and finish. Okay, so after we graph that, the next thing we're going to do is find the averages. So we need x bar and we need y bar. Okay, remember you can do it by hand, but I'm going to go ahead and do it on the calculator. So we're going to go to stat, and then we're going to hit enter for edit. Let's go ahead and clear list 1 and list 2, so arrow up and hit clear and enter. Okay, so under L1 I'm going to list all the x values. So I'm going to have 1, 3, 10, 16, 26, and 36. And then L2 I'm going to enter all my y values. Okay, now that I have all those entered, I'm going to go back to stat, over to calc. I'm going to hit the number 2. So you can scroll down and hit 2, or if you just hit the number 2, it works the exact same. So hit 2, and then some of you can just hit enter on your calculator. Some of you need to scroll down to calculate. Okay, so on the calculator, the first one, x bar, is 15.333. Scroll down, y bar is 102.833. Okay, remember the line of best fit, I have to graph this coordinate point here. So x is 15.33, y is 102.833. Remember I have to label the point too, so I'm going to draw an arrow and say this is x bar, y bar. Okay, now go ahead and draw your line. So remember, as long as roughly the same amount of points on each side and it goes through the x bar, y bar. Okay, so we already did part C. So now if we do part D. Hi.
Might spot clean your carpet. Is that okay?
Yeah, that's okay. I'm just recording a lesson, so.
Okay.
You're fine though.
A little noise won't bother you?
No, you're fine.
Okay.
Okay, so now we need the equation of the least squares line. So if we go to stat, over to calc, remember we're just going to hit number 8, and then either hit enter or scroll down to calculate. Okay, so the best fit line, we know it's y equal, or the least squares line, sorry, is y equals A, which is 33.69. I'm going to round to 3 decimal places, so 696. So A plus B, which is 4.509 times X. Okay, and then the last part, a calf is 7 weeks old. What does the line predict the weight of the calf will be? So it's 7 weeks old. This is the age. And up here we know age is the X value. Okay, so this is our X. And then weight is the Y value. So that's what we're solving for. And we're using this equation here. So we're going to have Y equals 33.696 plus 4.509. And then instead of X, we know that the calf is 7 weeks. So we're going to plug in 7. So we should get 65.259 kilograms. Okay. Remember, you will have to memorize these calculator steps for your test, so make sure you understand the calculator part. Here is your homework assignment. You remember your test will be on Tuesday, so we have 3 more sections to cover still. This video will remain on my website for a while, so if you had any trouble, you can go back and watch the video. And then also, if you had trouble, just email me and I'll find a way to help you.